All right, here we go again. Section 2.2, power rule. Today's, what a great day today is. We're looking at the shortcut to the derivative. Yes, there is a shortcut. So we don't have to take the limit as h goes to 0 of f of x plus h minus f of x all over h anymore. But you still need to know that because it is very important to you and it's important to us as calculus students. So, rule, what is the shortcut? If we give you the f of x, the function, is equal to some variable to an exponent, and it's going to be a constant, it's going to be a number. So if I give you a variable to a constant, then the derivative, we can multiply that exponent to the front, and then we can subtract 1 from the exponent and give that to, or give the new exponent to that variable. So this works if we're in polynomial looking form. It's not going to be exactly polynomial form, but polynomial looking form. What does that mean? That means it's going to be a coefficient, a variable, to an exponent. That's the only way it's going to work. It doesn't work with fractions. It doesn't work when we multiply things together, multiple variables. It has to be a number times a variable to an exponent. That's why we call it the power rule. It's got to be to a power. All right, so let's go ahead and dive into some examples, and you're going to see what I mean by that polynomial looking form look. So example 1, we have 3x to the fourth. So we have a coefficient, we have a variable, and it's to an exponent. So we can go ahead and take the derivative and find the derivative. So f prime of x is going to equal. We're going to take that exponent, we're going to multiply it to the coefficient, or to the front. So we get 12. The variable is going to stay the same, and then we're going to decrease that exponent by 1. So we get 3. So 4, we'll take the old exponent, we're going to multiply it to the coefficient, and we're going to decrease the exponent by 1. That's your power rule. If you got that, we're good to go. I'm going to throw you several examples. We're going to throw them on the quicker side, just so you can see them. So 2x to the fifth plus 3x squared minus 5x plus 1. Being all these terms are being added together, we can take the derivative of each individual part of this. So this is in that form. So 5 times 2 gives us 10x to the fourth. Multiply the 2 to the 3, we get 6x, decrease the exponent to 1. Minus 5x. Okay, 5x is to the first power, so we take 1 times 5 gives us 5x to the 0. What do we know about x to the 0? That's equal to 1. And negative 5 times 1 is just negative 5. So we can actually get rid of that x to the 0. What about 1? Well, if we have plus 1, we can write this as plus 1x to the 0, right? Because anything to the 0 power is 1, and 1 times 1 is still 1. The derivative of this, well, we take 0 times 1 gives us 0, x, and then to the negative first. But 0 times x to the negative first is still 0. So there is no derivative there. And hopefully that makes sense to us if we think about just the part of y equals 1. If I get rid of the rest of this stuff, y equals 1 is a horizontal line. And what is the slope of a horizontal line? It's 0. What are we looking for? We're looking for the derivative. The derivative is the slope of the tangent line, or the slope of that line. The slope of that line is 0, so the derivative is going to be 0. So the derivative of any constant is going to be 0. Hopefully that made a little bit of a sense. If not, ask the questions. Example 3 here. We have the square root of x. So this is not in power form. So we have to go ahead and rewrite it as x to the 1/2 minus 2x plus 1. And I'm going to go ahead and label that as f of x so we don't get confused if we're working with the derivative or we're working with the original function. Now I can go ahead and find the derivative, f prime of x. 1/2 is going to come to the front. I'm going to decrease the exponent by 1, so we get negative 1/2. Negative 2x, the derivative is going to be negative 2. Plus 1, the derivative, again, we have a constant, it's going to be 0. Since we have a horizontal line there. So this is a good enough answer. Multiple choice, you may see this as taking the negative exponent, taking it to our denominator, minus 2. So you may see it in that form. You might find a common denominator. The common denominator here would be 2x to the 1/2. So we'd have 1 minus 4x to the 1/2. So any one of these threes is answers is acceptable. I would leave it as the top part. Multiple choice, be able to get it to this part. My rule of thumb again is get it to the answer that's provided to you so you can get to what we're probably looking for on a test or a quiz. In example 4, I can't do that yet. I have to rewrite this. F of x, the third root of x squared. We're going to write that as x to the 2/3. Our numerator is the exponent on the inside. Our denominator is the index, or that number above that radical symbol. 3x minus 2, our derivative then is going to be 2/3 x, decreasing this by 1. 2/3 minus 1 gives us a negative 1/3. Plus 3, derivative of 3x is 3, derivative of negative 2 is 0. A quick way of being able to find what this value is, if you take the numerator minus the denominator, that'll give you the new numerator. 2 minus 3 gives you negative 1 over the denominator of 3. Just a quick way of doing that if you forget how to subtract 1 from a fraction. Example 5. We can go ahead and look at this one. We have 3x squared plus 5x minus 2 over x. Again, we don't have a power here. We have to rewrite this as a negative exponent. So we can write this as minus 2x to the negative first. So our derivative is going to look like 2 times 3 gives us 6, x to the first, plus 5, minus, we're going to multiply the negative 1 to the negative 2, so it's going to make it a plus 2x, decreasing this by 1, negative 1 minus 1 gives us negative 2. Again, we could manipulate this. It's really up to you. We could take that negative exponent back to the denominator. We could also find a common denominator for all of this. So we get 6x to the third plus 5x squared plus 2 all over x squared. Again, any one of those three answers would be acceptable. You're probably looking at the last part in order to be on a multiple choice test or quiz, but any of them is acceptable. What happens in example 6 here? We see that we have a fraction, a nice big old fraction. So the only thing we can do with this is go ahead and break it up, kind of decompose that fraction. So our f of x, we can rewrite this as 2x to the third divided by x, minus 5x squared divided by x, plus 3x divided by x, minus 2 divided by x. Cleaning that up, our original function, we get 2x squared minus 5x plus 3 minus 2x to the negative first. And we're going to bring that to the top since I know it has to be in power form. I can go ahead and now take my derivative. 2x squared gives me 4x, negative 5x goes to 5, 3 goes to 0, and negative 2x to the negative first goes to positive 2x to the negative second. I'm going to leave it there. You can play around with it if you want to get to a different answer. In example 7, we're going to throw some radicals in the top and the bottom, numerator and denominator. I'm going to first write it as x to the 1/2 minus 2. I'm going to go ahead and start decomposing that fraction. So we have x to the 1/4 on both of my parts, or both my terms. I'm going to go ahead and clean this up. X to the 1/2 divided by x to the 1/4. If we have common bases, we can subtract those exponents. 1/2 minus 1/4 gives us a positive 1/4 on the top. We move this x to the 1/4 to the top as a negative exponent. So now I can go ahead and find my derivative. I'm going to multiply my exponent to the front, so I get 1/4 x. Decreasing by 1, I get negative 3/4. Again, 1 minus 4 gives us negative 3 over the same denominator. Negative 1/4 times negative 2 is positive 1/2 x. Negative 1 minus 4 gives us negative 5/4 as our new exponent. Again, you could make these positive by taking them to the denominator if you wish. The last thing I want to show is writing that equation of the tangent line. Notice we do this quite a bit. So it's a fairly large part of calculus, being able to write the equation of a tangent line. given a function and given an x value or even given a point. So if you recall, we need to have the slope. The slope comes from the derivative. So we're going to find the derivative of the function. That gives us 6x plus 5. We're looking when x equals 0, so we're looking for f prime of 0. That gives us 6 times 0 plus 5, or 5. So that's our slope of our tangent line. We also need the y value. We know that y equals, when x equals 0, plugging in our 0, we get 3 times 0 squared plus 5 times 0 minus 1, or negative 1. So our point is 0, negative 1. Our slope is 5. We can write the equation. Y plus 1 equals 5 times x. Again, good enough answer. You could manipulate it to get to a different answer. Extended response, I would leave it just like this. Hopefully you've enjoyed seeing that shortcut, and you'll use that shortcut so we don't have to spend so much time taking those limits anymore. There are quite a few other rules we will get through as the weeks go on. Good luck and enjoy.